CS 3351 Digital Principles and Computer Organization. Topic is Sequential Circuit, presented by Devi Visalakshi, Assistant Professor of CEC Department, Rohini College of Engineering and Technology. Introduction to Sequential Circuit. In combinational logic circuits, the outputs at any instant of time depend only on the input signals present at that time. For any change in input, the output occurs immediately. So here this one is a diagram for the combinational logic circuits. N input variables we are giving and then M output variables we are getting. In sequential logic circuit, it consists of a combinational circuits to which storage elements are connected to form a feedback path. The storage elements are devices capable of storing binary information either 1 or 0. The information stored in the memory elements at any given time defines the present state of the sequential circuit. The present state and the external circuit determines the output and the next state of sequential circuits. So the inputs are giving the combination circuits and then memory elements are mixed with the combination circuits and then it will get the output. This is sequential circuits. The output variables depends not only on the rotary channel selected knob on an old-fashioned TV is like a combinational. Output selects a channel based only on its current input. The position of a knob, the channel up and the channel down push buttons on a TV is like a sequential circuit. The channel selection depends on the past sequence of up and down pushes. So here's the comparison of combinational logic as well as the sequential logic. So first we see about the combinational logic. The output variable at all time depends on the combination of input variables. But in the sequential logic, the output variable depends not only on the present input but also depends upon the past history of inputs. Based on the memory, in combinational logic, memory unit is not required. But in the sequential logic, memory unit is required to store the past history of input variables. Like speed in combinational logic, faster in speed, but in sequential logic, slower than combinational circuits. In combinational logic, it's easy to design. In sequential logic, comparatively harder to design. Combination logic examples are adder, subtractor, decoder, encoders, magnitude comparators. But in sequential logic, the examples are shift registers and counters. So this is the hierarchy of logic circuit. So it's having the two classifications. First one is a combinational circuit as well as the sequential circuit. Again, the sequential circuit is divided into two categories. First one is the synchronous sequential circuits and next one is the asynchronous sequential circuit. In synchronous sequential circuit, having two categories. First one is the Moore circuit as well as next one is the Milley circuit. Asynchronous sequential circuit having two classifications. First one is the fundamental mode as well as the pulse mode. So difference between the synchronous as well as asynchronous sequential circuit. Asynchronous sequential circuit in based on the memory elements are clocked flip-flops. In asynchronous sequential circuits, memory elements are either unblocked flip-flops. The change in the input signals affect memory element upon activation of clock signals in the synchronous sequential circuits. The change in input signals can affect memory element at any instant of time. This is for the asynchronous sequential circuits. The maximum operating speed of the clock depends on time delays involved in synchronous. And because of the absence of clock, it can operate faster than synchronous circuits in asynchronous sequential circuits. Synchronous circuits are easy to design, but asynchronous circuits are more difficult to design.